Hi, everybody. Hayes' World of Math. Welcome back. I'm Mr. Hayes, and I need a haircut. But we're going to put that to the side because we have to get you ready for the AP exam. So we're going to talk through questions out of Chapter 8. Matches up with the practice of statistics. I think we're still using the 5th edition, the one with the flamingos on it. Regardless, this is confidence intervals, and that's probably why you're here. All the notes that I'm doing are located down below in the link. Feel free to grab those, use whatever you want. Go ahead and hit subscribe and the like button and all that other good stuff that YouTube viewers should do. Let's get going. So the first question that we're going to look at is out of 2018. And there was this environmental science teacher at a high school, large population of students. They wanted to estimate the proportion of students at the school who regularly recycle plastic bottles. Teacher selects a random sample of students to survey at the school. Each student goes into the teacher's office one at a time and answers the question, do you regularly recycle plastic bottles? Based on the responses, a 95% confidence interval was built, and it was calculated who said yes, and it was calculated between 0.584 and 0.816. Hopefully some things are already going through your head in terms of how things were built and how things were done. We're going to get to all of that as we go. But again, remember, as with my theme, answer the question that's being asked. So in this case here, the first question is how many students were in the sample selected by the environmental science teacher? Now, this right here can often throw people just because there's a fair amount of algebra in it. Just don't panic and you'll be fine. So remember, confidence intervals is our mean plus or minus our margin of error. So in this case here, our margin of error is going to be z times the square root of p times 1 minus p all over n. So we need to find a few things first because what we want to get is n. So that means we need to figure out the z, the x bar, and the p. So we can plug those parts in and solve for the missing part. Now for x bar, you just you average the ends of your confidence interval. So I take 5.84 or 0.584 and 0.816, add them together, divide by 2, and I get an average of 70 right over here. So that is going to be my x bar. To find your margin of error, I probably should have labeled this, my apologies. So you just need to find the distance of the end of the confidence interval. Apparently my writing is awful. Between one of the ends and the margin. Or what you could also do is do the same thing as what we did up here, but subtract it and go from there. Either way, your margin of error is 0.116. So we know that this is going to equal 0.116. And so we don't care about the 0.7 for right now. We do because we're going to have to use it on the inside. But what we're going to end up doing here then is we're going to say, okay, this 0.116, the margin of error, is equal to my z-score. Since it's 95%, we're going to use 1.96. And then since this is my p-value, actually I shouldn't have used x bar, I should have used p, my apologies. Or p hat. So right up here, we've got 7 times 0.3 all over n. Okay, there, now I feel better. So we go through this. So p hat's 1.16, or we're going to plug this in. So margin of error is 0.116, z-score of 1.96. My p-value is 7. 1 minus 0.7 is going to be 0.3, and n is the part that I'm looking for. So to do that, then, what we're going to need to do is obviously solve for n. A couple of things. Again, you probably want to isolate the root first. So if you isolate the root, I went through and I divided by 1.96, and I'm squaring both sides. And when I do that, and apparently, obviously, I ran out of room. So then I get 0.21 over n equals this squared, multiply both sides through by n, divide by this, and I get this mess right here. I'm not plugging anything in until the very, very end. When I type all of that stuff out, I get n is equal to 59.95. Now remember, that is always the smallest value that we can have, so we need to go a little bit more conservative, so we're going to push it out to 60, because if we said 59, it wouldn't work. So that means that means this teacher had 60 students in terms of what was going on, right? So 60 students came and answered this question for this confidence interval. Now, given the method used by the science teacher to collect the responses, explain how bias might have been introduced and described how the bias might affect the point estimate of the proportion of all students who responded yes to the question. So then for this one here, what's going to end up happening is this. Now, a couple of things. Think about what happened. It was a random sample, but how did they answer the question? So they went in and they talked to the environmental science teacher. And so bias may have been introduced due to the teacher asking the students the survey question directly. Students may answer they recycle either due to thinking that the environmental teacher would prefer that or not wanting to admit that they don't recycle. And so because of that, what ends up happening is that your p-hat value is going to be much higher, or your p-hat estimate for the population is going to be for the proportion is going to be higher than what you want. Notice here I didn't necessarily specifically say what type of bias we're talking about. One of the reasons for that is because if you're wrong with that, then it's my understanding, and readers, please feel free to correct me down in the comments, that if you say something wrong like that, they have to take some points off. But if you don't necessarily say what type of bias it is, but again, because what's the question asked, it's saying explain how bias might have been introduced and describe how the bias might affect stuff. It didn't say what type of bias, it just said explain what bias or how bias would affect things. Then they can give you full credit for that. All right. So then for the next part, they ask you, okay, now what happens if the statistics teacher, because we're pesky like this, was concerned about the potential bias. So to obtain a less biased survey, they did the following. They took a random sample of 300 students. Each student was given the instructions on how to respond. In private, they flip a coin. And if heads, you must respond no, regardless of whether or not you recycle regularly. And if there's tails, you're going to truthfully respond yes or no. Because the expected number of students, what is the expected number of students who would be required to respond no to the coin flip? Well, okay, the expected number of that would just be half of the 300, right? So you would have 150 students you would expect to have to say, nope, I don't recycle. So then from there, what must the results showed a sample of 213 out of the 300 students responded no. Based on the results of the sample, give a point estimate for the proportion, and again, I've circled that we're saying a point estimate and a proportion just to make sure that we're answering what we're supposed to of all students that must respond, or that would respond yes. So out of the must answers, we have 150 who have to answer no, okay? And we're just assuming it's 150, might be more, might be less, but the expected value is close enough. So we're going to take out of those 213, we're going to take away 150 of those no's. So that means we have approximately 63 real no's out of the 150. Then from there, we have 87 students who answered yes, right? Because that's the difference between the 213 and 300. So that gives us 150 students total who were not told to answer no. So then from there, we have 87 out of 150. That gives us a 58% value of students who would say, so the approximate participation who say yes, they recycle is now 0.58. All right. That's it. All right, let's take a look at the next question. We're going on to the year of 2015. To increase business, owner is running a promotion in which the customer's bill can randomly be selected to receive a discount. When a customer's bill is printed, the program in the cash register will randomly determine whether the customer or not receives a discount on their bill. The program is written to generate a discount probability about 0.2%, probability of 0.2, so that is giving 20% of the bills a discount in the long run. However, the owner is concerned that the program has a mistake and that the results of the program are not generating the intended long run proportion of 0.2. So the owner selected a random sample of bills, found only that 15% of them received discounts. Confidence interval for P was made, so it's running from 0.15 to plus or minus 0.6. So because of that, so they're going to ask you consider that confidence interval. And does the confidence interval provide convincing statistical evidence that the program is not working? And the answer is no, because when you build the confidence interval from that, it can go all the way down to 0.09, or up to 0.21, and 0.20 falls within that confidence interval. So since it's a plausible value, we don't have we can't say it doesn't work, right? Part 2, part 2, does the confidence interval provide convincing statistical evidence that the program generates a probability of 0.2? Well, no, because anything inside the confidence, remember, confidence interval is, we are 95% confident that the confidence interval catches the true proportion. It can be anywhere from the bottom to the top. 0.2 happens to be one of those, but there are anything within that confidence interval is a plausible value. So this doesn't prove that 0.2 works. It just says that we can't not prove that it doesn't work. All right, now for the fun one. On part B, they ask you for, they're going to do a second random sample. They're going to go 4 times the size of the original sample. In the second sample, 15% also receive the discount. Determine the margin of error based on the second sample of bills that would be used for this. Okay, so the p-value is the same. We can't change that. Z-value is the same. We can't change that. We don't know what n is. And so what I did here was, so here's my margin of error. So I've got the formula as n. Now, all we know is that in the new one, we've got 4 times n. So I just went 4 times n on the bottom. When I do that, the only thing that's different now between this one and this one is the fact I've got this 1/4, the square root of 1/4. So I pull that out. Notice that this part right here is the same as what we have up over here. So when I take the square root of 1/4, it's going to be 1/2. Now you may remember that us talking about something when you're increasing the sample size, it's the square root of whatever the proportion difference is. Okay, or if you want to cut something in half, you have to go 2 to the 4th power larger than that. Regardless, we know that the new sample size is going to be half of whatever the new sample size, the margin of error is going to be cut in half from the old one. Since we know the old one is 0.06, the new one is going to be half of that. And so half of 0.06 is 0.03. So that's going to be our new margin of error. They then go on to ask, based on the margin of error in part B that was obtained for the second sample, what do you conclude about whether or not the program is working as intended? Justify your answer. So the new margin of error of 0.03 would create a confidence interval that runs from 0.12 up to 0.18. Because again, they said the sample, remember the proportion in the middle of the sample was 0.15. So since 0.20 is outside your confidence interval, that's convincing evidence that there's something wrong with the machine, because if it's truly going to be doing that, that 0.2 should be within the confidence interval. All right. So that's 2 free response questions. I think the next one, I didn't necessarily go through it, but I believe it has, instead of being proportions, it's based on numbers. Yeah, this one, you could end up doing its percentages as well. So anyway, so they like percentages apparently. So please go ahead and give this a shot. We will see you next week after at least my classes are assessing. We'll pick up with significance testing, and then we will go on from there. So hopefully you will find that helpful. And then the way that our book does it, that after we do significance testing, then we will actually do difference of populations separately from both of those. So we'll go on from that, and then we will wrap up with chi-squared, etc. So talk to you soon. See you later.